Most of the naturally occurring substances which we see around us are mixtures. To study the individual components and to use them, we need to separate them. So, now we will discuss various methods of separating the mixtures. So, first of all we will study how to separate a mixture of solids by using various methods. The mixture of two solids can be separated by using a suitable solvent, say mixture of sugar and sand. Which solvent should we take? Think over it. Water will be taken because water will dissolve sugar, but sand will remain insoluble. So, in a beaker a mixture of sand and sugar is taken and water is added to it, and the mixture is constantly stirred with the help of a glass rod. Sugar will dissolve, but the sand will not dissolve. Now, we can easily separate it with the help of filtration using a funnel fitted with a filter paper. So, by pouring the solution slowly into the funnel, the sugar solution will pass through the filter paper and will get collected in the beaker, and the sand will remain on the filter paper. So, we can separate sand from sugar solution, and to separate sugar dissolved in water, if sugar solution is slowly heated and evaporated, what will happen? Water will evaporate, leaving behind the crystals of sugar. So, like this we can separate a mixture of sugar and sand. Also, we can separate sulfur and sand. Now, which solvent should we use? Because sulfur does not dissolve in water. So, let us try some other solvents. Sulfur dissolves in carbon disulfide. Carbon disulfide. So, here instead of taking water as a solvent, we will take carbon disulfide solvent and dissolve this mixture into carbon disulfide and then filtering. Sulfur will dissolve in carbon disulfide, leaving behind sand on the filter paper, and then from the solution of sulfur in carbon disulfide, sulfur can be separated. To separate a mixture of solid and liquid, we will study now the methods used to separate. If the solid is insoluble in the liquid, the method used to separate them will be simple: filtration. The apparatus is shown here. So, to separate a mixture of chalk or sand which is insoluble in water can be done by filtration, by taking a funnel and the filter paper. Filter paper, if it is round in shape or in rectangle in shape or square in shape, it should be folded twice to make a cone like structure and fit this cone in the funnel. Make the surface of the funnel wet so that it sticks to the funnel, and now you can pour a mixture of chalk or sand in water. Chalk or sand does not dissolve in water, and when you filter, the chalk particles or sand particles will not pass through the filter paper, only the water will pass through it, and chalk or sand will remain as residue on the filter paper, and clear water will be separated in the beaker kept below. Now, this method of filtration we use in our daily life also. Try to remember where do we use it. For filtering the tea, we use tea strainer in the house. So, when tea is boiled, after boiling with tea leaves, to separate tea leaves from tea, a strainer is used. Tea leaves remain on the upper surface of the tea strainer because they cannot pass through the fine pores of the tea strainer, and the tea is collected in the cup and easily can be used. Another method to separate solid from liquid is the method of centrifugation. Now, let us first of all study about centrifugation. Now, centrifugation is the process of separating a solid from a liquid by rotating the mixture or by spinning the mixture at a very high speed in a centrifuge, in a apparatus called centrifuge. Here a simple diagram has been made and these show 4 test tubes. They are attached to one place and the center place, from the center place the tubes are rotated at a very high speed. These test tubes are filled with equal volumes of the mixture of solid and liquid, the solid which is insoluble in the liquid. And when these test tubes are rotated at a very high speed, the solid particles settle down and then they can be easily separated like this. Solid particles suspended in a liquid, it is before centrifugation, and after centrifugation what happens? The solid particles easily settle down. Now, you will say solid particles will settle down even if we keep it for some times, but that takes time. To do it fast, easily we can separate solid particles from the liquid by centrifugation. Even in the labs, this method is used to separate precipitate from the liquid, from water. Precipitate settles down by centrifugation and then it can be separated by decantation. Also, in the dairies, the dairy owners, they separate cream from milk by centrifugation. Milk is rotated at a very high speed and the cream separates and it settles down. Even butter can be separated from the milk, but in this case butter does not settle down, butter floats over the remaining part of the liquid, remaining part of the milk, and can be separated. If the solid is soluble in a liquid, then how to separate it? Here we have done the solid is not soluble, but if the solid dissolves in a liquid, then how to separate it? In that case, the separation can be done by evaporation. You all have studied what is evaporation. When a liquid changes into the vapor state by heating or on its own also, then the process is called evaporation. Now, if you dissolve salt in water, it dissolves. If you dissolve common salt in water, it dissolves. How to separate them from water? So, let us take one example. To separate salt from water, common salt which we use in our house, dissolve it in water, it forms a clear solution. Now, how to separate them? You have to evaporate it by heating. Even if you keep it for some times, water will slowly evaporate, leaving behind the salt. But to do this process faster, salt solution should be heated with the help of a burner. Water evaporates, leaving behind the salt. Even from sea water, which contains a large percentage of common salt is separated from water by evaporation only. Sea water is stored in shallow tanks and it is allowed to evaporate on its own with the help of the heat of the sun. Water evaporates, leaving behind the salt, and then this crude salt obtained then can further be purified and can be then sent to the market. You must have seen blue black ink at home. Nowadays, of course, it is not much in use, but this blue black ink is a mixture of a dye in water. Now, how to separate it? Because it is soluble in water, it also can be separated by evaporation. Now, here the black ink is not heated directly because this black ink will decompose on heating. So, it is heated over a beaker containing water. So, water is heated first of all, and then water evaporates and the steam formed then heats the ink taken in a watch glass which is kept over the beaker. So, something will evaporate. Now, think what is that substance which is evaporating. Water is evaporating, leaving behind the ink, blue ink or black ink, whatever it is. So, now this ink has been left here, it is a mixture of solid and liquid, but and solid has completely dissolved in the liquid, in water, and we have separated it by evaporation. Another method to separate solid from liquid is chromatography. Now, what is chromatography? In simple words, chromatography is the method of separating two or more solids dissolved in a liquid. Depending upon the solubility, their solubility should be different. Now, here an activity can be performed in the lab. This you can easily do it in your lab in the school. Take a sketch pen, a black sketch pen. The method which we use will be paper chromatography, because chromatography is of many types, and here we are using paper chromatography. A thin strip of filter paper is taken as shown in the diagram, and a black sketch pen is taken. Now, by this method we can show that the ink is not a pure substance, it is a mixture of many substances. A line is drawn, say about 2 centimeters from the edge, and a very small spot is made on this line with the help of the black sketch pen. The filter paper is then clamped inside and suspended inside the cylinder filled with little water, so that the lower end dips in water, and then keep it for some times. After some times you will see that water starts rising up. The ink is soluble in water, it dissolves in it, and the different components present in the ink rise up with the water. Now, these substances, solid substances present in the ink have different solubilities. So, they rise up to a different heights and can be separated. After some times you will find various colored spots at different distances, and these spots may be pink, blue, green in color. These are all the colored spots, and these are the solid substances present in the ink. And this paper now is called chromatogram. Now, this paper chromatography can be used to separate the solid substances which are present in the ink dissolved in water. Now, if two liquids are mixed together and they do not dissolve in each other, like kerosene and water. Now, kerosene does not dissolve in water. So, how to separate a mixture of two immiscible liquids? This can be done by using a simple apparatus known as separating funnel. Now, in the separating funnel the mixture is poured. Kerosene is light in weight, kerosene will remain at the top and water will remain at the bottom, it is heavy. It is allowed to stand for some times, and then after some times the stopcock is opened and water is collected first of all, and then closing it in another beaker, kerosene oil can be collected, and so two immiscible liquids can be separated by using a simple apparatus, that is separating funnel. Even oil and water do not mix with each other. So, oil and water also can be separated by using a separating funnel. Now, during extraction of iron, the impurities have to be separated from the iron, the impurities are called slag, which is lighter in weight, which floats over the surface of the molten iron, and here also it's also separated by the same method. Slag remains at the top and it is removed from the top, and molten iron is heavy, remains at the bottom, can be separated. When two liquids are miscible with each other, then how to separate them? To separate a mixture of two miscible liquids, the method used is distillation. Now, let us see what is distillation. Distillation is evaporation followed by condensation. In this process, first of all, a liquid is heated so that it converts into vapors, and then these vapors are cooled to condense and to get back the liquid. So, let us now study how a distillation is done to separate mixture into the miscible liquids. The apparatus is set like this. This is a distillation flask in which the mixture of acetone and water is taken, which are miscible with each other, fitted with a cork, and a thermometer is also kept. Thermometer is used to record the temperature, because acetone and water have different boiling points. The boiling point of acetone is 56 degrees centigrade and that of water is 100 degrees centigrade. So, there care has to be taken that the temperature does not rise beyond 56 degrees centigrade, so that only acetone evaporates, because we have to separate them from each other, and this distillation flask is then connected to the condenser, water condenser. This is condenser. Now, this condenser consists of a inner tube and an outer jacket, through which water is continuously circulated. From here the water is continuously sent in, and from here it continuously goes out to cool the vapors flowing through the inner tube. And this is a beaker is placed here so as to collect the liquid. Now, when the apparatus is set like this, the heating is continued with the help of a burner, and the temperature has to be maintained. It should not rise above 56 degree centigrade. The acetone will vaporize first. As its boiling point is less than that of water, vapors will rise up and pass through this inner tube. Here it will get cooled by the water flowing through the outer jacket of the condenser, and on cooling it will condense and will form acetone and will be collected in the beaker. Water will be left behind. So, here temperature has to be kept constant, it should not rise. So, by this method we can separate mixture of acetone and water. Another method is also there, that is called fractional distillation. If the difference in the boiling point of the two miscible liquids is less than 25 Kelvin, in that case another method is used, fractional distillation. Now, fractional distillation is a very useful method to separate the various components from the petroleum, because petroleum is a very useful product and which is a mixture of various fractions which can be separated by fractional distillation. So, let us study now how is fractional distillation done and how is it different from distillation. Now, it is more or less same as distillation. The only difference is a fractionating column is also used. Now, this fractionating column is packed with glass beads. Now, these glass beads are there because vapors rise up, will condense back and form the liquid. Now here also thermometer is used to keep the temperature constant below the boiling point of that component which has low boiling point. So the temperature should be fixed here also. Now apparatus is set in the same manner as in the case of distillation. Heating is continued by a burner. Both alcohol and water will form vapors, but the vapors of water will condense back and vapor of alcohol also will condense back and form liquid. But when the temperature is maintained at 78 degree centigrade, which is the boiling point of alcohol, alcohol will vaporize and the vapors will pass through the condenser. It will pass through the inner tube of the condenser where it will get cooled by the flowing water and will condense and be collected in the beaker kept below the condenser. So alcohol can be separated from water, water will be left behind. The only thing to be kept in mind is the temperature, which should remain fixed, which should not rise above 78 degree centigrade, which is the boiling point of alcohol. You must be aware by now that air is a homogeneous mixture of various gases like oxygen, nitrogen, argon, carbon dioxide, water vapors, etc. Now how to separate these gases present in air? Let us study right now. As you have studied that gases can be liquefied by applying pressure and by decreasing temperature. So let us now study how the air can be separated into the various gases. Air, first of all, it is filtered to remove the impurities present in it like dust particles, etc., and then by increasing the pressure it is compressed to a very low volume and then the temperature is decreased because the compressed air becomes hot. So it should be cooled. On increasing the pressure and decreasing the temperature, it liquefies and forms liquid air. Now liquid air is then slowly warmed in fractional distillation column. The various gases present in liquid air will then separate according to their boiling points. Now nitrogen has the lowest boiling point, minus 196 degree centigrade. So it separates out first and then separates argon, which has boiling point minus 186 degree centigrade, and then oxygen separates. Last of all, its boiling point is minus 183 degree centigrade. Also the percentage by volume, all of you know that oxygen is present 20.9% by volume and nitrogen 78.1% by volume and argon is only 0.9% by volume. Also a schematic diagram is shown here how separation of gases can take place from liquid air. Now here this is a filter to filter out the impurities from air. The filtered air is then passed through this part where air is compressed by these pistons at high pressure. Now the compressed air becomes hot and this hot compressed air is then passed through this compartment where this hot air is cooled down by this freezing cold water. Water is continuously being circulated to cool the air and now the air has cooled and compressed air is then now passed through this separator. Here from this separator solid carbon dioxide first of all, because carbon dioxide solidifies. On cooling, it is separated. It is also called dry ice. It is an important component. It is used to keep the things cool, and from this separator then liquid air is passed through this compartment through this jet from expansion jet, and here the liquid air then forms the gases. Nitrogen first of all separate on warming a little because it has lowest boiling point, and then argon separates, and then it is passed through another compartment where liquid oxygen separates because it has the highest boiling point as compared to nitrogen and argon. So, this is how different gases present in air can be separated. Now, we will study how to get pure solid from an impure sample. For this, let us perform an activity in the lab and also learn how it can be done. A pure solid can be obtained from impure mixture by the process of crystallization. Now, what is crystallization? Crystallization is a process of separating a pure solid in the form of crystals from a solution. So, this activity can be performed in the lab by collecting the apparatus. Take say about 5 grams of copper sulphate and dissolve it in minimum quantity of water in a china dish by stirring. Filter the copper sulphate solution by the help of funnel and filter paper. If there is any impurity in the solution, it will be left behind on the filter paper. And now this filtered copper sulphate solution should be taken in the china dish, and it is heated with the help of the burner as shown in the diagram. Heating should be continued till some of the liquid is left behind, till a saturated solution is obtained. It has not to be heated for a long time so that only solid is left behind. It has to be heated in such a way that a saturated solution is obtained. Now, extinguish the burner and keep the china dish on a table, cover it with the filter paper and leave it for cooling for a day. Next day, what will you find? You will find the crystals of copper sulphate. So, this is how pure copper sulphate can be obtained by crystallization from the impure sample. A solid also can be separated from a mixture by evaporation, but crystallization is a better technique as compared to evaporation, because some of the compounds on heating decompose, so that we cannot get the compound because it has decomposed, and some of the compounds char on heating, like sugar. Sugar becomes black on heating. Also some of the impurities also dissolve in water or any other liquid if it is taken, and those impurities will also crystallize along with the solid, and it will contaminate the solid. So, crystallization is a better technique. Let us now discuss some of the very important applications of crystallization. Crystallization is used to obtain pure common salt from the salt obtained from the sea water, because the salt obtained from sea water is not pure, it is impure, it contains some other salts also. Also it is used to obtain pure crystals of alum, that is fitkari in Hindi, from an impure sample. So, there are various applications of crystallization. And now let us discuss how water can be purified in water works. Water is supplied to various houses from the water works. First of all, it is purified and then it is sent to the houses. Here the water is stored in the water reservoir and then it is passed to another tank where the solid impurities are allowed to settle, and this is called sedimentation tank. So, the solid impurities settle down. Then it is sent to the another tank, that is called loading tank. Here the suspended impurities which still remain in the water are made heavy by adding some substance, so that these impurities become heavy and they settle down. Then the water is passed through the filtration tank, which is packed with fine sand, gravel and coarse gravel. When the water is being filtered here and is passed to another tank, that is called chlorination tank, where chlorine is mixed to kill the bacteria, and then this water is sent to the houses where it can be used. So, this is how water is purified before sending it to the various houses. To understand the difference between a pure substance and a mixture, we should know about the physical change and the chemical change. In the previous chapter, you have studied about the physical properties of matter, like rigidity, like color, fluidity, melting point, density, boiling point, etc. Now, you are all aware about the fact that water on heating changes into water vapors. Water, when it is heated, it changes into water vapors, and on cooling it changes into ice. Now, think about it. Is it a physical change or a chemical change? Ice is also solid form of water. Water vapors are also gaseous form of water. Only the physical state has changed. Interconversion of state is a physical change. So, let us see what is a physical change. It is a temporary change. Now, during a physical change, no new substance is formed, only the physical state is changing, no new substance is formed, no new substance is formed, and it is a reversible change. The change is reversible. Let us see some more examples, like breaking of a glass tumbler, cutting or tearing of paper, glowing of electric bulb. When the current passes through the bulb, bulb glows, and when the bulb is switched off, it is a physical change. There is no change in the bulb. So, think about some more physical changes, like dissolving the salt in water. Is it a physical change? There is no new substance formed. We can get back salt also, and we can get back water also. So, it is a physical change in which it can be reversed. The physical change can be reversed. Melting of wax is a physical change. Now, think about some more activities, like burning of a candle. Now, when the candle is burnt, the wax melts. So, melting of wax is a physical change, but the candle burns and forms a smoke, that is a chemical change. Just now we studied interconversion of states of water is a physical change, but when electric current is passed through water, it decomposes into hydrogen and oxygen gas. Now, this is a chemical change and not a physical change, decomposition of water into hydrogen and oxygen. So, can you get candle again after burning? If you burn a paper, can you get back paper again? Now, at home milk is converted into curd. Now, can we get milk back from curd? So, curdling of milk is a chemical change. So, let us see what is a chemical change. A chemical change is a permanent change. It is a permanent change. Now, in this change a new substance is formed. New substance is formed. And the change is irreversible. Think about some more examples. Growing of a plant grows from seed to a big plant, digestion going on inside the body, respiration going on inside the body. So, these are all chemical changes, and when a chemical change occurs, a chemical reaction also occurs. So, chemical change is also called a chemical reaction, because a chemical change occurs, then a chemical reaction occurs and new substances are formed. If hydrogen burns in oxygen, it will form water, and when water is decomposed by passing electricity, then it decomposes. So, these are both examples of a chemical change.